Hey there, in today's video I will show you how to create this pattern here. Let's go. So I will start showing you based on a very simple example, and then I will walk you through what I did to apply it to the shape that I actually want to use it for, right? So let's go. We will need a surface. So I will use the plane surface command. Where is it? There it is. You can just say, I don't know how big you want it to be. And then you have this big surface, right? And then we use diamond panels. Plug it in. And now you can see we have these diamonds in here. I will just see. Right, so this is maybe a little bit too fine. We can also go a little bit less. But the goal is basically to achieve a ratio between the U and V divisions that you have rather square shapes overall, right? So I think that's still a little bit much, but maybe also here. So I think that should work for our purpose. So we have these panels, and we basically want to take each of these panels and scale them down based on the distance to a certain geometry, right? So we already have these panels. That automatically also gets rid of the small triangular ones at the edges. So we only have the ones that we actually need. So we still need the geometry to pull towards. So I would just say grab edge, plug in my surface, and then I have 4 edges, and I just want the longer ones. So I say larger than, then I need the distance or the length of these curves. I plug it in, and there are 20, 100, 20, and 100. So we can just, anything bigger than 30 will be basically removed from the list, right? Or will everything below 30 will be removed from the list when we use a call pattern. And here the output is a true false list. True false, true false, true false. Now it's just 4 entries. We could also basically just write that pattern. It's even the standard pattern. No, this one it's different. But it would be false, true, false, true, false, true, right? Anyways, we have it. Plug it in here. We take our list. And now all that's left is the 2 curves along this dimension. So we have the geometry that we want to use as the fading geometry, right? Closer to those lines, I want the diamonds to be smaller than in the center. So let's prepare everything for that. Okay, so I have these panels. I want to scale them, but I have to scale them about a certain position. So I need the center point of each of the panels. And that the area command gives me the centroid. And now I scale them basically uniformly by whatever factor you type. Okay, that's not the one that I need. Now we can scale it from everything from 0 to 1, right? 1 is completely plane, everything is tangent, they touch, and everything in between. But as I mentioned, I don't want to just use a planar function for that. I want to actually use the distance to these curves. So the geometry that pulls are my lines, and the points that I need the distance to are the center points of the panels. So actually, let's get rid of this, just so to keep it a little bit more clean. Also, this guy can go down a little bit. Yes. Okay. So now we have the distances. And now we have to remap those distances to be a number between 0 and 1, right, in order to apply it as a scaling factor. So we take the distances, plug it in the remap, then we use the bounds in order to define the source domain. In the domain, it basically has the smallest number and the biggest number. So the smallest distance and the furthest distance. And then we construct a new domain, which is supposed to be our target domain. And for this purpose, we do something between 0.05 and 1.00, right? And we also take that for the bottom, slide it up to the top. Now we have our target domain. Now we use the graph mapper. So just basically the very typical way to do these things, fading patterns, is with the graph mapper. And now we need to scale again because now we have defined a list of factors, scaling factors from 0 to 1 and everything in between that is corresponding to the list of points that we have and to the panels, right? So now I can just take these panels and scale them. I will scale them still, not the area but the centroid, to their center points each. But now I will apply these factors. And now you can see what happens, right? Then they are big where the distance to my lines is the furthest, and they are small where the distance is really close. And now with the graph mapper, we can really control how this distribution is supposed to go. Do we want a broad midsection, or do we want to rapidly increase in scale, right? So now we have all the freedom to express ourselves artistically. And here we can also define the minimum size, basically, which is the domain start, and the maximum size also, right? So there you can even get some additional variation. So I think that's pretty all right. Maybe we do it like this, and maybe I do want it a little bit smaller in the center. So now we basically have the pattern. So what you can do now is basically extrude these guys, unit Z, and now you can just bake them and do a Boolean operation with your geometry, and then you have what you basically want. It's very simple, nothing wild here. So now let me show you how to apply it to a different kind of geometry. So if I hide this for a second, where are we? Right, so I still, my detox watch design, right? So I want to apply the pattern to the upper surface, but only to like the outer area of it before it bends inwards. So I isolated this part that I want to apply it to and went even further and separated this section out. So I'm basically, let's make this more clear. I basically just split the surface like this and imported that surface. So there we have it. So this is the imported surface, right? And now we do everything that we did before. So I apply the diamond patterns, and what we see here is that it reads the surface as a whole without the trimmed section, or with the trimmed section actually. But that's not what we want. So again, we have to apply some sort of filter. But overall, I applied this division because I feel like it's appropriate where I need it to be, right? And then I do the same with the larger than slider. So I calculate the area of these and say that if the area is below a certain number, and the bound helps me to identify those numbers, right? So I have to move between 0.002 to 1.8. And I figured that everything that's smaller than 0.9 will be disregarded. So I also take my diamond panels and I cull it, and then this is what I'm left with, right? And here we have a break because that's where the surface has its seam. But there are several ways to fix it. But for me, at the moment, I don't really mind, right? I just leave it. So we have our panels, and then we need, again, the geometry that we want to fade towards, right? So I use the wrap edge command from my surface and take the naked edges. And because it's split the upper one in two curves, I have to join them back, but it's only these two rings, right, that I have as a reference. And then I do the same thing as I did before. We use the pull point to define and figure out the distance. So I take all these points and I let Grasshopper calculate the distance from each of these points to my curves. And that's what I get here. And now we do the same operation with remapping the numbers, right? So I get the domain, I remap the distance values, I define a target domain, I plug it into my graph mapper, and then I scale these surfaces accordingly. And similarly as before, you can do the adjustments, like what do we need, what do we want, right? And also here, do you want them to be bigger or smaller? That's up to you to decide. So you can really also try different things. For example, now this becomes much more varied. Maybe it's interesting. And then if you make this smaller, then the difference is smaller again, right? So there's loads of ways to do this in an interesting way, like this as well, right? You don't have to start from 0 though. More constant, more extreme, like everything is basically possible here. So let's go back to the Bezier curve. Then we scaled it, right? And then basically I want to extrude them in order to be able to do the Boolean operation with my geometry. In order to extrude them, we could just extrude them upwards, but I think it makes sense to extrude them in the normal direction based on where the surfaces are on my original reference surface. So I take my surfaces and I use the evaluate surface component. And this is something that I don't really understand why it shows up like this. Because this is my reference, right? These are my surfaces and these are my points. So that's what I give as input. Maybe I can check the data structure, but I think because it works, there's nothing surprising going on really. They have the same data structure. So I'm not really clear about what happens here, why it shows up in this weird fashion. But also, if I basically take my geometry here and I apply the extrusion according to the normal that I get from the evaluate surface, then it does look like it did it correct. It looks like it was extruded in the normal direction of each of the individual faces and not according to these crazy patterns here. So I'm wondering if it's just a graphic issue or if I missed something else. But because it's working, I can just continue now and basically bake this, group them, and that's it. And now you say, but yeah, you have a gap here. I mean, yes, I do. But if you look from the top, maybe we can just take the respective curve, remove it as a reference. So again, let's take these and mirror. I want to select the center. Just give me the center, boy. And mirror it by 90 degrees. That looks a little bit weird. Maybe that looks better. So now I just mirrored the missing ones and I have a complete set without a gap here, right? So because it was just a few ones, I think you can do it that way. Group them back together. And now, let's say we have this guy and we give it some thickness. And let's do offset surface, flip it, and I don't know how much. So now this surface has some thickness to it, right? We can skip it. This is now a volume, it's a closed poly surface. And here we have a lot of closed poly surfaces. And now we just have to pull it up a little bit. So there's actually crossing in. And now it should work. Boolean difference. Select the group. And there you go. So this is now my surface. And if you want to close the gap, you can still, right, and then offset surface by, let's do 0.4, a little bit less. Not solid, flip, yes. Then let's get rid of this guy. So now we have another surface on the inside. And then I make solid again. And now it's closed, right? You can still merge them if you want. And now you have this geometry. And now, I mean, you can still fine tune it, right? Maybe you don't need the very small ones at the edge, then remove them. by filtering them out. Or you want to fill it the stuff. That's a lot of work. So maybe you should fill it beforehand. But that's basically everything already that I wanted to show you. With this pattern, you can now make beautiful renders, beautiful work, beautiful patterns, surface textures. And that's it. I hope you liked it.